In this lesson, we're going to be talking about how to evaluate functions. Evaluating functions is a topic that you've done before, but since we know the difference between a function and a relation now, we can focus on evaluating just functions. And the way that this is different is because of function notation. So now that we know the difference between a function and a relation, we can denote or write a function in a specific way to communicate that it is a function. So the equation can be written in a form called function notation. This is a very important vocabulary word. We use this as a quick way to evaluate functions for a given input. So previously you've seen equations written y equals 2x minus 8. Equations like this can be relations and functions or just a function. So to show that this is a function, we use function notation. To show that it's a function, we are going to write the equation like this. As you can see, the two equations are very similar with one difference. Instead of y equals, we write f parentheses x parentheses. That first part, the f parentheses x, is the part that tells us that 2x minus 8 is in fact a function. We don't have to test to see if it is. We're being told that it is. And the way that we read this is f of x equals. So the way we would read the above function is f of x equals 2x minus 8. And again, the purpose of replacing that y with the f of x is to communicate that 2x minus 8 is a function. So let's take a look at how we can evaluate these. To evaluate a function for a specific value, we're going to substitute in the value for x. So again, this is a skill that we have done before. However, it's written and the problems will look a little bit different. And these can get a little bit more complex than we've seen in the past. Taking a look at number 1, f of x equals x plus 7. We want to evaluate this function for not just one value, but for 3 values. We want to evaluate it for f of 5, f of negative 1, and f of negative 3. That means we're going to use this function 3 different times, and each time we're going to replace x with a different number. So looking at part A, f of 5, we're going to replace x with 5. And 5 plus 7 equals 12. So for part A, f of 5 equals 12. We're going to use that same function for f of negative 1 in part B. And we're going to do the same thing. We're going to substitute in negative 1 for x, so negative 1 plus 7 equals 6. So f of negative 1 equals 6. And then we'll do the same thing for part C. Substituting in the negative 3 for x, so negative 3 plus 7 equals a positive 4. So f of negative 3 equals 4. So the big differences in evaluating functions now is that we're using function notation to communicate a little bit more clearly what we want somebody to do. I want you to go ahead and highlight number 2 through 6. And then let's take a look at number 7 together. Number 7 reads slightly different. It says g of x equals negative 1/2 x plus 9. G of x and f of x are the same thing. They're both saying that the equation is a function. By saying g of x, we're simply using a different variable. For a, b, and c, you can see that we are substituting in 3 different numbers into this equation to evaluate the function. So we would solve it the same way. For a, negative 1/2 times negative 8 plus 9. We're replacing x with negative 8. And then you may use a calculator or you can do the math mentally. Negative 1/2 times negative 8 is a positive 4 plus 9 is 13. So g of negative 8 equals 13. And then we'll do the same thing for b. G of negative 2. We're going to replace x with negative 2. So negative 1/2 times negative 2 plus 9. Negative 1/2 times negative 2 is a positive 1 plus 9 is 10. So g of negative 2 equals 10. And then for c, g of 0 equals negative 1/2 times 0 plus 9. Negative 1/2 times 0 is 0. 0 plus 9 is 9. So g of 0 equals 9. Go ahead and highlight number 8, 9, and I'm going to look at number 10 with you. Number 10 says g of x equals the absolute value of x minus x squared. So again, we're going to evaluate these the same way. You just have to remember you're going to solve order of operations and remember what absolute value means. So when we evaluate g of 4, we're going to replace x in both situations with 4. Then we treat absolute value similar to how we treat parentheses. We're going to complete all of the math inside those absolute value bars first and then find the absolute value of what we have left. So according to order of operations, we need to do the exponent first and then subtract. So the absolute value of 4 minus 16, because 4 times 4 is 16. And then the absolute value of 4 minus 16 is negative 12. So now that I've done all of the math inside my absolute value bars, I can find the absolute value of negative 12. Remember, the absolute value is the distance from 0, and distance is always positive. So the absolute value of a number is always the positive value of that number. So the absolute value of negative 12 is positive 12. So g of 4 equals 12. To evaluate g of negative 7, we're going to do the same thing. The absolute value of negative 7 minus negative 7 squared. Notice, since the value I'm substituting in is negative, when I substituted it in the second time, I put it in parentheses. And this is to make sure that I say negative 7 squared, not just 7 squared and then tacking on my negative. You'll get two completely different answers. So when solving this, we're going to square negative 7 first, which would result in negative 7 minus 49, because negative 7 times negative 7 is a positive 49. And then negative 7 minus 49 is negative 56. And the absolute value of negative 56 is a positive 56. So g of negative 7 equals 56. And then lastly, g of negative 3. We're going to treat this one just like or very similar to b. But instead of substituting in negative 7, we're going to substitute in negative 3. But then we're going to make sure that when we substitute it in that second time, we're putting it in parentheses. So the absolute value of negative 7 minus 9. Because negative 3 times negative 3 is a positive 9. Which would give us the absolute value of negative 16. And the absolute value of negative 16 is a positive 16. So g of negative 3 equals 16. Let's take a look at number 11 together. Well, I realized I messed up. Let's go back and look at C. So hopefully you have caught my mistake before I did. So I substituted in the wrong number here at the very beginning. So that should say negative 3 minus negative 3 squared. So that's the absolute value of negative 3 minus 9. So instead of doing that negative 7 minus 9, it's negative 3 minus 9, which is the absolute value of negative 12, which is a positive 12. So g of negative 3 is a positive 12. Sorry about that. Now let's look at number 11 together. Number 11 says an anthropologist used the length of certain bones of human skeleton to estimate the height of a living person. One of these bones is the femur. To estimate the height in centimeters of a female with a femur length of x, they use this function. H of x equals 61.41 plus 2.32x. First, it wants us to find h of 46. So this part is just like what we did above, where you're going to substitute in 46 for x and evaluate. I would recommend using a calculator for this problem to avoid any unnecessary mistakes. Once you've evaluated, then I want you in your own words to write what does this mean in context to this problem, because this is a word problem. So we want to go back and think about, well, what does this answer mean? So go ahead and highlight number 11. I want you to come back to that one in just a minute to finish it out. And then you can highlight number 12. I'm going to talk about it briefly. So it says, given the graph of the function. So still, again, we're told this is a function, and it wants us to evaluate the following values: negative 4, 0, 2, and 5. So this is asking us to do the same thing. But instead of substituting these values in, because I don't have a function to substitute it in, I have a graph. We're going to look at the graph. So remember, these values that they gave us, remember it was f of x. So these are our x values. So to evaluate f of negative 4, if I go to negative 4 on my graph, where x is negative 4, and I go up, I can see that that y value is a positive 2. So when we evaluate x of negative 4, it equals 2. So when you're evaluating it, you're finding that y value that goes with the x value. So you would do the same thing for B, C, and D.